process in the manufacture of ceramics is the kneading. The cake is taken from the filter press or vacuum filters, and then they are put into a pug mill, which is used to mix the materials in plastic or semi plastic state. Pug mills are of two types: vertical pug mill and horizontal pug mill. A vertical pug mill consists of a hollow cylinder which is either tapered at its base or provided with a horizontal outlet. A vertical shaft provided with knives at various heights is rotated mechanically in this cylinder. The material is fed at the top, which moves downwards owing to its own weight. The mass in the pug mill is cut into pieces and then forced into a chamber where the pieces are compressed into homogeneous mass by the rotating knives. These knives may vary in shape from flat to curved. The second type of pug mill are the horizontal pug mill. These mills also operate on the same principle as the vertical pug mill. However, since clay does not gravitate towards the outlet, it tends to turn with the knives. This movement is prevented by arranging counter knives. Trough mixtures which work on the same principle as horizontal pug mills are also used. In these two shafts provided with helical knives rotate in opposite directions. The cake is pressed towards the exit and is reduced on its way into a granular condition. Modern mills are also provided with vacuum chambers in which the packed clay is de-aired. Vacuum treatment improves the plasticity and homogeneity of clay bodies. It has been established that the evaporation of water in vacuum exposes the clay particles to the action of water vapor, as a result of which plasticity of the clay bodies is considerably increased. Next comes the throwing process. It is the process by which different shapes are given to the clay mass. In other words, throwing consists of shaping a mass in spinning clay between the thumb, fingers, and palms of the hands. The oldest method for this is the potter's wheel, which can be driven by the thrower himself or it can be mechanically driven. The thrower places a lump of plastic clay on the wheel head and then sets the head in motion. He wets its two hands and then holds the lump between them and squeezes as well as flattens it. He then gives a shape of an object by working the soft clay with his fingers, thumb, and palms. Articles other than round shape are formed in plaster molds by different methods. The simplest mold is that which is used for ordinary bricks and consists of a wooden frame. For articles of irregular form, plaster of Paris molds are used. Plaster of Paris absorbs water from the clay and does not adhere to the soft clay body, so that the clay can be easily removed from the body. The next process in the manufacture of ceramics is known as the jolling. Jolling is a mechanical process of making a large number of similar articles economically. In this process, the body is formed partly by a plaster of Paris mold and partly by means of a tool having a partial outline of the article to be made. The body in the plastic state is placed into or on a mold of plaster of Paris, which is fixed on a rotating wheel. This wheel is known as jolly and is pressed to shape by profile. So, jolly is a device for carrying a tool termed as profile, which gives shape to one side of the ware, the other being formed by the plaster mold. For example, in the case of a cup, the outside is formed by the mold and the inside by the tool. Similarly, the face of a plate is shaped by the Paris mold and the back of the plate by the profile tool. Automatic jolling machines have also been developed for cup and plate making. Slip casting. Slip casting is the next process which comes in the manufacture of ceramics. It is a process of giving shapes to clay wares from clay liquid. The slip used for slip casting is prepared from plastic body by adding a small amount of sodium carbonate, sodium silicate, or caustic soda. When any of the chemical is mixed with plastic clay, it becomes thin enough to be poured out of the vessel. In other words, clay particles lose their plasticity and turn into a liquid. Usually 0.2 to 0.3% of these chemicals are added, enabling the thin clay liquid to get filled in hollow casting mold, which is made up of plaster of Paris of the article to be made. The inside of the mold is found to be covered with a layer of clay, some water having been absorbed by the plaster. In this manner, a uniform layer of clay body is deposited around the inside of the mold. When the inner layer acquires some thickness, extra clay liquid is poured, and if this layer is left for some time in the mold, it becomes hard. After drying, whole casting is taken out of the mold. Slip casting has several advantages such as preparation of article of complex shapes, preparation of refractory articles, use of cheap and reusable molds, manufacture of heavy plumbing ware, dinnerware, art objects. mm, the next process which comes in the manufacture of ceramics is the pressing. Pressing is the process used for making plastic, semi plastic, and powder bodies. Plastic bodies are used in the manufacture of tiles, roofings, drain pipes, etc., and they can be prepared by placing clay inside the molds made in two halves and then pressing either manually or mechanically. In making semi-plastic body, the plastic body is dried, powdered, and mixed with small amounts of water and oil. Oil avoids sticking of the body to dyes when pressed hard. For making powdered body, very powerful presses are employed as they do not possess the property of flowing like plastic or semi-plastic bodies. Powdered body is used in the manufacture of walls and floor tiles. Pressing in steel tiles may be wet pressing, dry pressing, or semi dry pressing. The next process in the manufacture of ceramics is known as extrusion. This method consists in forcing the plastic paste through a die or mouthpiece of the required shape. Vertical and horizontal presses have been widely used for this purpose, but de-airing pugmils are also used for this purpose. The shape of the extrusion die corresponds to the cross section of the rod, uh, tube, or bar to be extruded. After extrusion, the material is cut into pieces of suitable length. The process of extrusion has been used in the manufacture of bricks, rods, pipes, bars, etc., and in the manufacture of porcelain, stoneware, and refractory material. The next process in the manufacture of ceramics is the turning process. Turning is carried out on lathes, and before turning a ceramic body, it is essential that the body should be dried to a reasonably hard state. In case of medium and large articles, the body may be in semi hard state. Small articles such as sparking plugs are turned in hard state. In pottery manufacture, turning is frequently used after jollying or casting. Thus, grooves or undercut profiles can be turned in cups, pots, and vases produced by either jollying or casting. In the manufacture of insulators and other technical porcelain, turning is used for producing grooves, cylindrical tubes, bushings, etc. The next process in the manufacture of ceramics is the drying process. Articles made by the above mentioned methods are dried well before they are found fit for firing. Drying is most essential because imperfect drying may cause cracking of the article during firing. Apart from the nature of the body used, the speed of drying depends upon the following factors. The most important of the factor is the shape of the articles. If the ratio of the surface area, that is the area which is in contact with the drying air, to the volume of the article is greater would be the speed of drying. Next is the temperature of the surrounding air. The greater the temperature of the air used for drying, the more water is extracted and evaporated into the air in a given time. Uh, Then comes the rate of the air circulation. The rate of drying also depends upon the rate at which air containing water liberated from the article being dried is replaced by fresh warm air not containing vapor. Hence, quicker the moist air is replaced by fresh dry air, the quicker is the drying. Last but not the least is the humidity content of the surrounding air. If the surrounding air contains water vapor already, then it would not take as much moisture out of the air as would dry air.